Hello friends, welcome to our channel, that is a Hariharan Express channel. Today I will discuss regarding on circular shift. Previously I have already discussed that is a logical shift, arithmetic shift, and today I will discuss regarding on circular shift. And a circular shift is one kind of advantage, or if we go through disadvantage of previous shift like logical shift and arithmetic shift, some limitation is there. That is when data shifted from left to right or right to left, in that case what happens, the left data or right data is discarded or that is rejected. Okay, then what happens, that data never be reused. That is the disadvantage of previous shift. But when we go through circular shift or circular shift approaches, then those data is reused. There is no loss of data. In that case, previous case what happens, it is loss of data. But here what happens, there is no loss of data. It can be reused. This is the advantage of a circular shift. And same serial, that is serial data we will consider, and serial transfer of information we will consider, that no loss of data if we go through circular shift. Similarly, we divide that is this shift into two ways. One is left shift, another is right shift. Okay. So first we focus on that is a circular left shift. Okay. So now you see circular left shift. Okay. So take an example. Previously we have already discussed regarding on any bit, maybe 4 bit, 8 bit or any other bits, then different bits of data we also consider. Okay. Now see what are the data, that is, so let us consider 4 bit data we will consider, no problem. 4 bit data, any 4 bit data we can consider, doesn't matter. Okay. Now we see, whenever I go through this one 4 bit data, suppose 1001 for example, then we apply left shift. Left shift means what? That is a data transfer from right to left, okay, towards this. That is a, here is a right, okay, here is a left normally. So here this bit is a LSB bit, we can tell as a, it is one MSB bit. Okay, right to left. Then how the data, whenever how the data transfer from right to left, and how the rejected data or discarded data again reuse for this particular technique or approaches, that is you will see. Okay. Now see, same thing, very simple way, as it is logical shift, same 4 digit we will consider, sorry, 1 2 3 4, this is extra bit. Okay. Now if we go through left, means right to left. Okay. If we go through right to left, then what happens? What you will do? This is a shift to this position, because first position cannot be occupied. This, since it is left, right to left, this position shift to here, so it will be 1. Again similarly this will be 0, this will be 0, and this one is rejected, this one is rejected as per the, that is a logic shift, we know that. But here what happens, if you go through logic or that is a arithmetic, then what happens? In that case this empty space is filled by 0 normally, but since we rejected this one, that one also reuse for this particular shift operation. Okay. So this one again add with this one, this particular space. Okay, that will be, that is a 1. This one added with or this one add with the end of this particular this shift. Okay, so there is no loss of data. Here you see very simply there is no loss of data. This data again we add, so definitely it will use, it will useful. So there is no loss of data here. Okay, so this is the basic concept whenever you go through this is circular left shift. Very simple way we go through. Suppose 4-bit data, 4-bit data shifted from as it is, that is logical that is operation, logical shift operation as it is. But whenever we discarded or rejected the data, that data again added with a, that is a empty space, that is in LSB. We can add with a LSB because we transfer from right to left, since it is a circular left shift. Okay, and you know that this is a MSB. MSB already fill up, but it will add with a LSB. Okay, this is the concept regarding on circular left shift. If we go through, this is the concept. Again, another part also there, that is a, we can write another is a, that is a circular right shift. Right shift. Just reverse. Similarly, take an example, very simple example we can take. 4-bit we can take, doesn't matter, and any data you can take. Suppose here is 1101. Okay, any data, doesn't matter, as you like. 4-bit data we can take it. And here what happens, right shift means here MSB we can take this data. Here is a MSB, here LSB, and data flow from left to right. Okay, in this way, left to right. Since right shift means left to right, it will flow. So in this case, you see how it will flow. Okay. Now you see here what happens. Same thing we apply. Here the data we can write here. Here data we can write here. It is 0. Okay. And this data is rejected or discarded. Rejected or discarded. Okay. Since it rejected or discarded, then what happens? Why you lose that data? Again that data, this particular data, again it attaches with the empty space, because this is empty space. Okay. This data is added with the empty space. Okay. So now all data is shifted, there is no loss of data. Okay. This is the basic concept regarding on, that is circular right shift. Okay. These two important that is circular part, or that is two shift, that is left shift or right shift of circular shift. These two shift is very, very important. Not very important, but it is the basic approaches we will consider. And one advantage we can consider in this way, like there is no loss of data if we go through circular shift operation. Okay, that is the advantage. It has advantage, that is there is no loss of data. So question may arise, which shift micro operation having loss of data? We can consider if we go through logic micro operation or we go through that is arithmetic micro operation, then definitely loss of data. Okay, either that is left hand side or right hand side, whatever the, that is as per the that is operation, we lost some data. And the question may be arise, in which shift there is no loss of data or no loss of bits of information. Okay, we can tell as, or the answer will be that is a circular shift, either left shift or right shift, it doesn't matter. In a circular shift there is no loss of bits of information. Information maybe it will be something changes, but there is no loss of bits. Okay, because bits is different, bits means value is different. Whenever I calculate this decimal value, it will be different, but there is no loss of bit. Every bit will use, and whenever use its position, it's as per this position value will be changed, but there is no loss of bits. It is the advantage of this particular circular shift. Okay, so thank you very much. This is the basic concept of a circular shift. So thank you very much to watch these videos. Please subscribe my channel, and if you want to give some comments, you can give me to improve our videos, to improve our progress our channel. Okay, thanks to all to watch these videos, and your support is very very important to progress this channel. I promised I will give many number of problem and solution through this channel. Many students, many researchers also, and many teachers also can get benefit whenever they will see my videos, or through my channel. Whatever the videos are available with different that is topics I will cover. Okay, not only subject, other part is there, that is tools and some research papers, different concept I will explain. Then many people can benefit whenever they will use my channel. Okay, or they will see my videos, then they can get benefit. Okay, thanks to all. Thanks.